Hello, math analyzers. Let's put chapter 8 to bed with a nice little exam review before we move on and start using all this really fun right triangle trig information. So, much like with our quiz, we're going to start with a right triangle. It's got a theta listed in there. Let's label the sides of it first, just based on the theta. We know that 17 being the largest side is going to be your hypotenuse side. From the angle theta in question, the side across from it here, the 8 is the opposite side, and this side next to it here, the 15, is the adjacent side. So then we can kind of go from there. I did tell you should probably memorize these Pythagorean triples since they appear so often. So is an 8, 15, 17 a Pythagorean triple? Yep, it is. Let's circle that guy. And what we want to do here is list the sine theta ratio. So sine theta is opposite over hypotenuse, so that'd be 8 over 17. Cosine is adjacent over hypotenuse, that's 15 over 17. And the tangent is opposite over adjacent, that'd be 8 over 15. And you can use any one of these three ratios you just found for theta in order to find the value of theta in the triangle. So make sure your calculator is in degree mode to start, and I still happen to be in degree mode, so I'm good. So I'm second mode, quitting back out to my home screen where I'm going to press second and sine, and then I'm going to type in 8 over 17, and I'm just going to prove that I could use any of these to you guys. So I get 28 degrees. If I round to the nearest degree, theta is 28 degrees. But let's just prove that with the other ones. Second and cosine is 15. Oh, how about 15 divided by 17? And then in that parenthesis, and we get, yep. And last but certainly not least, because why not? Tangent would be 8 divided by 15. And we get, so whichever one of those you want to use when asked that question, feel free. Okay, we got that again and again. I do just want to say, you can do this again here and check the answer key. This is not a Pythagorean triple. Okay, so no for this guy. Yes, because any multiples of a Pythagorean triple are themselves a Pythagorean triple. So this is a 3, 4, 5, all the sides multiplied by 2. Okay, just a reminder on that front. Moving forward. Okay, use your graphing calculator to find the following trigonometric ratios, round to the nearest 10,000th. So we're going to plug in and check these guys out. We just had these on our quiz as well, so probably won't be anything too crazy here. But because we know the degree, you do sine and the angle measure, and then this, because we're in degree mode, spits out to us that ratio, that irrational, non-repeating, non-terminating decimal, that in ratio form with this function of sine at this angle is the proportion of the opposite side divided by the hypotenuse side. So if I knew that ratio and I divided it out, this is what I would get as a result. Okay. Round to the nearest 10,000th is 4 decimal places. So 0.3420. When I say 4 decimal places, I really do mean even if it's a 0 there to write it. Okay, typically. Let's just look at cosine 30 because we're going to be doing a lot of that in chapter 9. So cosine 30 is 0.8660. Okay, that'll sound very familiar when we get over to chapter 9. And another one that will be very well used in chapter 9 is 45 degrees. So tangent of 45 is, 1. Interesting. Just kind of a real quick cosine of 90, right? So you can remember this will be something that you see an awful lot of in chapter 9. I know I'm saying that a lot, but you'll see very soon how these things will play out a lot, okay? So that's just plugging those in. Here's a few triangles where I have a side labeled X. You need to make the decision to use Pythagorean theorem or a trig ratio. to solve for x in this triangle. So you state that first and then show your work to solve for x. So both of these will be present. And on your test, I have designated these in certain sections. So like this section right here on the test, you're just going to plug those in versus this section, you'll pick Pythagorean theorem or trig in the Google form. Then you'll show me your work for solving for x. So just a real quick, this is Pythagorean theorem because I know two sides and I'm asked for the third. This is trig because I know one side, I know an angle measure, I'm asked for a second side. So that's how I know the difference about which one to use, okay? When I'm using Pythagorean theorem, obviously I use a squared plus b squared equals c squared as my equation. C is always the hypotenuse side, so in our case, 16 squared goes on the hypotenuse side. A and B are interchangeable legs, so it really doesn't matter which is which, okay? So I do know that this is 64, so what I'm going to do just to quickly get from this to x squared equals a number is I'm going to take how about 16? 16 squared minus 8 squared, because I know I'm subtracting this from both sides, right? And I get 192, which we know is not a perfect square. It is evenly divisible by a few perfect squares. Trying to think of what the biggest one is, but you know what? I'm just going to go for 64 because I think it works. Again, that was just, I knew 4 worked. I knew 16 worked. I wanted to try and see if 64 worked. So that was just what I was trying. And so this, when I take the square root of both sides, comes out to be x equals no plus or minus because we're talking about a length of a side. So the minus is not applicable here. Square root of 64 is 8. Radical 3 is the leftover. Okay. Over here, so we're solving for trig. We know this angle. We know x is at the hypotenuse position. And that means that we need to know what this side is compared to our angle. It's the opposite side. So which of our trig functions uses opposite and hypotenuse? That would be sine. So you're looking at the sine of 57 equals 10.8 divided by x. Now, when x is your denominator in this ratio, flip the trig ratio and the x. So flip that around because it's like you cross multiply twice. And x is up here. Now you've got 10.8 divided by sine of 57. And again, we do know I'm already in degree mode, but be sure before you're typing this in that you're in degree mode. So 10.8 divided by, and I'm just going to put it in parentheses because I'm nice and safe about that. Having had an 83 growing up, I'm very careful about those parenthesis usages. What do we get? Okay, what did it say to round to? If I was rounding, it didn't, so let's round to the nearest tenth. That would be 12.9. Makes sense. Needs to be the largest side, so it definitely needed to be larger than this. I'll leave the other ones to you. We, of course, also had these special right triangles that we used those tables to help us figure out the appropriate values expressed in simplest radical form, right, for each of these triangles. So the idea is if you have a 45, 45, 90 right triangle, the legs in proportion to the hypotenuse are 1, 1, radical 2, which you can represent as x, x, and x radical 2. So when it comes to my x and my y here, x is another leg, y is my hypotenuse. So if I know that one of my legs is 10, then I know my other leg is 10, and I know my hypotenuse is 10 times radical 2, which is 10 radical 2. So my x value is 10. My y value is 10 radical 2. There you go. 30, 60, 90 with your tables. Got some room over here for tables. 30, 60, 90. When you have a right triangle and one of the other angles is 60, you know the third angle has to be 30, right? So that's where I'm getting this from. These are in the proportion of 1 radical 3, 2. So we can do x radical 3, and 2x, 2 times x. So what do I know? I know the little leg across from the smallest angle. So that's the 8. So 8 radical 3 and 8 times 2 is 16 is the hypotenuse. So x equals 8 radical 3 in this case because it's the long leg, and y is the hypotenuse, which is 16 in this case. Okay, those are from geometry, but I love those. I really like the way that those work and help you think about the proportion of the sides in relation to those special right triangles. And that is another thing that in chapter 9 is huge. So you definitely want to be able to do that very easily. Okay. And again, you have these answer keys, but I want to make sure that I do a few of them with you. So when we get to the word problem section of your Google form, right, the perimeter of a square is 56 meters. Find the length of the diagonal. So perimeter of a square means that all these sides are the same length, right? So there are 4 of them. X times 4 is 4x is our perimeter. So we know that that's 56 meters. So if you divide both sides by 4, right, 56 divided by 4 gives us 14. So that means x equals 14, right? Now, I want to find the length of the diagonal in this square. Okay. Diagonal is from one corner to the other. Let's pretend I got that corner exact. Let's not acknowledge that otherwise. Well, you just created, because this we know is a 90-degree angle, and you've cut this in half, you just created a 45, 45, 45 right triangle. 45, 45, 90 right triangle. So that's what you just created. And you know that the little leg is 14. So what's the diagonal in here? It's 14 radical 2. That's it. Draw yourself the picture and use that to help you. The area of a square. Oh, this is similar, right? So the area of a square is a square again. 49 feet. Well, we know the area of a square is x squared, right? So if you know that the area is 49, take the square root of both sides. We don't need a plus and minus because we don't have negative lengths of sides. And then the diagonal, same here, you just created a 45, 45, 90 right triangle. So 7 times radical 2 is 7 radical 2 for the length of this diagonal. So basically 2 different starting points for the same question. One using perimeter, one using area. I definitely use one of these on your test. So make sure you know how I did both of those and created those 45, 45, 90 right triangles. Proportions of the sides. You also really want to make sure you remember how to draw these pictures, right? So if the picture isn't provided, so I'm going to give you one like this where the picture is provided. Okay. And then I'm going to give you some more like this where the picture is not provided. From the top of a fire tower, a forest ranger sees his partner on the ground. So fire tower. Right. Like in the Adirondacks. Oh, my perspective is just on point right now. So here's my little guy up here. Doo-doo-doo. And he sees another forest ranger down here. Hi. Wave. Partner on the ground. Oh, my perspective got off a little bit there. Oh man, that's what happens when you brag. At an angle of depression of 40 degrees. So looking down, we know angle of depression. This guy, 40 degrees. If the tower is 45 feet high. How far is the partner away from the base? There it is. So let's see, to the nearest 10th. Got it. We know 40. We want to know the opposite side. We know the adjacent side. That's tangent of 40 equals x over 45. There it is. That's it. If you think of this being your eye line, depression is the below and elevation is the up. Looking up is elevation. Looking down is the depression. So if you want to kind of go from there. So really, I just cross multiply and I get the x equals 45 times tangent 40. So let's plug that into my graphing calculator. Probably easier if I put 45 in the parentheses in my graphing calculator, right? And then times tangent of 40, because I have to end this guy with a parenthesis anyway. And I get 37.759. So round up to the nearest tenth of a foot. So 37.8 feet. Draw the picture, label, then determine, right? We knew from here, this is the opposite side, this is the adjacent side. So determine from that angle what's going on there. Okay. All right, if I give you the picture, I mean, obviously, right? Use it. So I'll leave you that one to try on your own. I definitely give you the picture on one of them on your test. A ladder leans against a brick wall. Got it. Brick wall. Yes, I take the time to do that. Look how pretty it is. Come on. Ladder. Okay. My perspective won't be as good this time. Whoa, hey, oh, hey. Yikes. This is not a ladder I'd want to be walking across. Okay. The foot of the ladder is 6 feet from the wall. So here to here is 6 feet. Got it. The ladder reaches a height of 15 feet on the wall. Find the nearest degree the angle the ladder makes with the wall. That's right here. There's your theta, the angle the ladder makes to the wall. So from your theta, we've got your opposite side, and this is your hypotenuse, right? Because this is your right angle. So this is your adjacent side, and which of my trig ratios uses opposite and adjacent? And that would be tangent again. So this time, because I don't know the angle measure, this is the second in tangent of opposite over adjacent, or 16 over 15. So that's what I'm now going to plug in. So second in tangent, and it's 6 over 15 that I plug in here. Because I'm finding the angle measure, I do the second and then I get to plug the ratio in. And to the nearest degree, that would be 22 degrees. There we have it. So anything I didn't do and you want to ask me about, go for it. You have the answer key. These are the questions on the test. They're just in a slightly different order as far as section goes. So I do my section on using the special right triangles first, and that would be the questions 1 through 3. And then these questions right here where you choose Pythagorean theorem or trig, and then these questions right here where you use the chart. Then there's a section that's just use your graphing calculator to fill in these trigonometric ratios, rounding to the nearest 10,000th. So make sure your calculator is in degree mode, because I did not put that in the test. So you need to remember to do that yourself. All right. And then the last section is these word problems. I definitely use either 13 or 14, one of those two. I definitely have one where I gave you the picture, and I definitely have 1 or 2 where you have to draw your own picture. Okay. That is it. That's the test. I think you got this. But math analyzers, if you need some help from me, please let me know before you take the test, Make sure you try this. Make sure you do it with the video. Make sure you check the answer key and make sure you check with me if you need anything. Because besides the fact that you need to pass this chapter 8 test, you need to use all of this next chapter and chapter 10. This is where the rubber really hits the road as far as using our trig goes. Okay. Good luck. I'll be seeing you very soon. Goodbye, guys.